Brent with TechToolSupply.com. If you haven't seen our last video, take a couple minutes and watch it. It talks about splitters and basic RF distribution. Some of the things we talk about in this video build upon the last video. Now, splitters and taps are completely different. When we talk about taps, they're also referred to as directional couplers. The mechanics of the device is completely different than a splitter. The way that a splitter operates, you have the same insertion loss between the input and all of its outputs. For example, if you had a 8-way splitter, you're going to have 11.5 dB of loss between its input and all 8 of its outputs. Taps are a completely different device. Taps have a very small insertion loss between its input and its output, which is typically -4 to, typically from a half dB to 4 dB, really depending on what the value of the tap is, and then it has a tap port on it. Now the loss on the tap port is normally noted on the front of the tap. For example, if you had a 30 dB tap, it's going to have a 30 on the front of it to let you know that's the loss between its input and its tap port. Now, taps have an input, an output, and a tap port on it. Now, companies do make taps that are 2-port, 4-port, 8-port. They make them with pin connectors for hardline. They make them with F connectors. There's a lot of different variations of them, but they all work the same way. Between the in and the out, depending on the value on the front of the tap, there's an insertion loss. If we had a 24 dB tap, the insertion loss between the input and the output is only going to be 1 dB. Now, that means if we had 30 dB coming into our input of this tap, the output is going to be 29 dB. Simple addition and subtraction, 30 minus 1 is 29. Now, to calculate the loss on our tap port, we're going to subtract 24 from 30, which means our tap port is going to be 6 dB. Now, if this was a tap that had 2 ports or 4 ports or 8 ports, each tap is still going to work the same way. Whatever value is on the front of that tap, you deduct that from your signal coming into the tap, and that will give you the output of it. Now, when you have multiple taps, let's say our input signal is 30 dB. And let's say that our target level for every location we have on here is 7 dB. The best way to calculate what size tap you need is to deduct your target value from your input signal. So if we have 30 dB coming in and we want 7 dB on the output, we're going to deduct 7 from 30, and that'll give us our target tap value. So 7 from 30 is 23. Unfortunately, they don't make a 23 dB tap value, so you have to go to the closest one. So in this case, we'll put a 24. 30 minus 24 gives us 6 dB. So we have 6 dB on the output. Again, to calculate the loss between the tap itself, the insertion loss on a 24 dB tap is 1 dB. You would have to look at your manufacturer spec sheet when you're designing this. You always want to have the manufacturer specifications there, because you're constantly going to be coming across questions as far as what insertion loss is this, etc. So if this is 1 dB insertion loss on here, we're going to have 29 dB on the output. Now, let's say that between the output of this tap and our next tap, let's say that we have 100 feet of RG6. Now, as we talked about in our previous video, at 1,000 megahertz over 100 feet of RG6, your loss is typically right around 6 dB. So let's say we have 6 dB of loss between this tap and our next tap. So that means that our 29 dB coming out of our previous tap, after going through the RG6 going into the next one, we're only going to have 23 dB of signal going in. We're still shooting for the same 7 dB input on it, so we're going to deduct 7 dB from 23, which means we're going to shoot for a 16 dB tap, which they do make. And that will give us exactly what we want. 23 minus 16 dB would give us our optimum 7 dB output. 16 dB tap, the insertion loss is going to change a little bit. On a 16 dB tap, the insertion loss is 2 dB. So now we're going to have an output here of 21 dB. And now we're on to our next tap. Same thing again. Let's say we have another 100 feet of RG6, so we have 6 dB loss there. So now our signal's down to 15. So the 15 minus 7 is 8. They do make a 8 dB tap, but most times when you find an 8 dB tap, it's going to be self-terminating. What that means is there's no output on it. The output on it is self-terminated inside of it. So let's say that in this case, this is the last tap that we have down the line. We could put the 8 dB tap in here and give us our 7 dB signal. And there's our small tap system. 3 taps. We start with 30 dB. This output is 6 dB. This one's 7. This one's 7. Now let's say this last one here, let's say that we did need to continue on. In this case right here, you would have to add on an amplifier of some sorts. Let's say a 30 dB amplifier, you could put a 30 dB amplifier on there and bump your signal back up. So we'll say after this one we have 100 feet of cable. So we have 6 dB of loss there. So our signal's at 15. We'll put a 30 dB amplifier on here. Then we go back up to our tap. So now our signal's back up to 45 dB. Plenty of signal now. This is the basic calculations for doing taps. Just simple addition and subtraction. Like I said before, if there was multiple outputs on these taps going to multiple TVs, the insertion losses may change, but you know the calculations that we just did, figuring out what the values are going to be the same. So I'm Brent with Installation Nuts and Bolts. Thanks for checking us out, and we'll see you next time.